Topic C. Here we're going to cover the range function, nested loops, and breaking out of loops. So let's get started with the range function. Now, I might have said already, for loops in Python are interesting because you're looping through an iterable as opposed to setting up an integer, setting up an exit condition, and setting up a step iterator. All of that is kind of built into the for I in range. So first let's cover what this range is. Range is a built-in function which generates an ordered list of numbers. The range is basically specifically designed for the for loop. So for I in range, boom, lower limit, upper limit is basically your standard for loop language, and the for I in range loop makes an index available to the user. So that index is going to iterate with the step. Here is the format. So the range is going to have a beginning index, an ending index, and a step. Very much like a for loop in other languages. So here's a breakdown of what each parameter does. The start, this is the starting number, the beginning index, the initial value of the, for number in range, for I in range, that initial number. This stop, the second one, is the number it never reaches. So that is the upper bound. So if you go for I in range 0 to 5, the loop is going to go until I is equal to 5. But it'll never be 5. So the value of I is going to stop at 4, one less. And last is the step, which is how many steps you take through when you iterate. Now, this is going to make a lot more sense when we see it in the program right now. Hello. So in this program, we are going to show and demonstrate how the range function works by creating some for loops. We're actually going to use the for I in range sort of code structure to build a times table as well. So let's just start by writing the most basic for loop. For I in range 0, 10. Now, start index, end index. Step is usually 1. That's the default for the step. And we can print I. So when we run this, you're going to see numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 10 sort of executions that happen. 0, 10 means whatever is indented will happen 10 times. But the I, the looping variable, is going to go from 0 to 9. Because 9 plus, a 0 value, that's 10 additions. Now, we can change the step here. We can change the step to be, say, 2. And now, you're going to see the step. It'll go from 0 to 2 to 4 to 6 to 8. When it goes to 8 to 10, it won't come through. You can step by 3. You could step by anything. I mean, you could step by a negative number, although that would probably crash. It'll never reach -1 because it'll never reach 10 if it's going in reverse. So it automatically creates an error. But we could have had sort of a -10 here, and the step could have been -1. So as you see, this is the lower limit, upper limit, and step. You have a lot of freedom in terms of how you use these. So right now I'm going to show you a very, very simple application for this. So say you want to make a times table. You got to get an integer input from the user. So we can do this in one step. Do 3 things at once. So num equals to int input, and now we got to put a string into the input where we prompt provide a number here. So here we can do a print statement that says a bit like, here is a times table for. So let's see, here's a times table for. So now that we have num, we can use num to do calculations with. So you can just say, use the looping variable and multiply I with num, and we're going to have a times table. Hint, there'll be something missing. See if you can predict it. Last chance. What's kind of wrong here and what's missing is we're starting with 0. And 0 is not a part of the 5 times table. 0 is not a part of the 7 times table, although everything else is correct. So this is just a case of moving up that starting index. Perhaps moving this one so we can finish at. So times table for 3 should finish at 30 and start at 3. See, 3, 30. Beautiful. So that is all you need to know for the basic for loops in combination with a range function which creates this custom iterable. In this program, we are going to use the for loop to check if a number is a prime number. So let's get started by doing something we've done in previous programs, getting an integer input from the user. So we're going to use num, our favorite name for a number. Num equals to int input, and then what do we want to put in here? Provide a number to test. So at this point, if you remember, we had this kind of candidate previously in our while factors. We can essentially do a very similar algorithm here. Essentially, the candidate was checking if num was divisible by candidate, then candidate was a factor. Well, with the prime test, if a number has any factor that is not itself or 1, then it is not a prime number. So we are in a situation where we can assume that the number is a prime number, and if we find a factor, then we'll set it to not. So we can have something like a Boolean, like prime equals to true. So every number is going to be prime until proven otherwise. So let's go and try to prove that a number isn't prime. So what we need to do is essentially divide the number by any other number and get no remainder. So to generate all the round numbers that are less than the number and greater than 1, we can do that quickly in the for loop structure. So for I in range, so we're going to start from 2, because any number is divisible by 1, 2, and we're going to go up to num. And we're going to say if num percentage I double equals 0. So if you can divide num by I and get no remainder, then prime equals to false. So just do a little comment here. If you can divide num by I and get no remainder, then num has a factor and is not a prime. It is that simple. Now, of course, we need to run this one. We can enter a for I in. Nothing really happens. We're going to need a separate if statement to test if the prime is true or not. So we can do an if statement afterwards and say if prime double equals to true, then we print number. And if that statement isn't true, that means if prime is false. Given that it's binary, I could have written if prime double equals false or else, they both would work. We can print num, comma, is not a number to test, 101. 101 is a prime number. 11, my favorite number, is a prime number. Let's try 500, it's round, is not a prime number. So it certainly appears to work perfectly. So this is actually a brute force algorithm. It tries every combination, and we will be able to improve it when we discuss, breaking out of a. But just for the purpose of some curiosity and perhaps giving you some fun stuff to do, you can actually test how much the improvements to the algorithm work. You can import a library, like the time library, import time, and you can measure how long this takes. So you can, take the time before and after. So what I normally do is something like this. Tick equals the time dot clock or time dot time. If you have any issues, you can use also time dot time if time dot clock doesn't work. I know that Windows and Mac don't actually perform the same. So you can measure how long that takes. That would include printing statement as well. So that could be talk, and you can print. So this is time before you really started, and this is time when you finish. Actually, sort of more accurate would be that you finish here when prime is either assigned to false when this whole loop has been completed. So this is really going to take very, very little time. I'm going to test this. If I say 11, it'll be, 9.6 to the power minus 6 seconds. But if we take a huge number, like, I don't know, that's going to take some time. Actually, I really should have tried like 1 million. All right, 1, 2, 3, 4, 5, 6. Those are 6 zeros. I can copy. I can actually stop you, and we can actually test. Okay, that is 1 million. Let's see how long that'll take. 0.22 of a second. And if we try 10 million, 2.14. So this is effectively a brute force algorithm, and what I'm setting you up here to do is, if you like, in your own time, if you feel up to it, you can try to change this algorithm and apply, different technique. You might even decide to step through these. You might not go for the full range and see if you can bring down this time. It's a good practice in terms of implementing these new coding structures that you've learned, and also thinking about algorithms. So in this program, we are going to use a nested loop. And we're going to use a nested loop to generate a list of coordinates. So, you're familiar with the Cartesian plane. We've got x and y. And let's say our Cartesian plane is 5 by 5. Of course, we have 0 as well. So we want to generate a list of all the possible dots. So the indexes are going to be between 0 and 4 for both x and y. And this is a really good use case for the nested for loop. So let's just write a for loop for x in range. If it's 0 to 5, in fact, we're going to have 5 different values of x. 0, 1, 2, 3, 4. So those are the 5 different values. And we're going to have 5 different values of y. And so there'll be 25 coordinates. So for y in range, 0, 5, we can print x, y. In fact, we can actually print an actual printable comma between x and y. So I need to run this. So these are all the coordinates. There'll be 25. And if you want to go back to those basic lists, we could put them all in a list and then print that list. So we can say coordinates equals the list, and we can create a special, like C, a temporary coordinate, and that would be equals to, I guess that you need like a string of x plus this comma plus string of y. And then you could coordinates dot. That would work pretty well. And then we can print coordinates. Let's try. And there they are in a list. So that's just a typical use case. In fact, like if you have one of those Python microcontrollers called the microbit, it's got a 5 by 5 LED grid, and you will end up using some nested for loops in using that.